and welcome to this joint Assembly Quality Podcast.
I'm Jennifer Pierce, multimedia editor with Assembly Magazine and the host of Assembly Audible.
And I'm Michelle Bingert, Managing Editor of Quality.
On Assembly Audible, we focus on the latest processes, technologies, and trends for assembling parts into finished products.
And on Quality's QCast, we interview subject matter experts on a range of quality topics, from the skilled workforce to stress.
Today, we're collaborating to explore an area where assembly and quality intersect: machine vision.
And we're here today with David Dechow. He's the founder and owner of Machine Vision Source. He'll be speaking at the Assembly Show this fall. His session is called Benefiting from Machine Learning in Machine Vision Applications. So, David, welcome. Thank you for being here today. We're excited to talk to you.
Thank you. I'm excited to be part of this podcast and also part of the Assembly Show. Looking forward to it.
Yeah, us too, for sure. So you'll be speaking at the show this October in Rosemont, Illinois. And can you tell us a little bit about how you decided to speak about machine learning?
Sure. Well, first of all, I think there's a certain amount of confusion about what machine learning is versus AI versus deep learning. They're all part of the same bucket in general. With machine learning being more a part of computer and data science, but a very close relationship to AI. And in many cases, people consider deep learning, which is a lot more familiar, I think, to most people, consider deep learning a part of machine learning. The thing is, it's a really valuable set of algorithms within machine vision that can help do simple classification, simple segmentation, and other tasks without having to go to the full scale convolutional neural networks that are part of the deep learning algorithms.
How is this utilized in assembly lines, and how do the latest advancements fit into or improve assembly applications?
Yeah, well, machine vision, and again, recently in the last 15 years or so, computer vision are just a huge integral part of assembly and quality in a wide variety of manufacturing. The industries are numerous, and we wouldn't even list them all here quickly. But the point of machine vision is to, in an inline process, and that's an important differentiation there, in an inline process, provide the quality inspections that need to be done on a part to ensure productivity, to ensure reliability of the part, to limit waste, and most importantly, to improve processes. Machine vision, to use kind of a relative descriptor, machine vision used to replace or to mimic the capability of a human inspector, can provide reams and reams of data that can be used upstream or in statistical analyses to improve the process. Kind of the goal of quality in general in assembly, right? But we use machine vision technology, cameras, computers, and so on, to extract that information autonomously and automatically in a real-time production, which is hard to do in a quality environment. Usually we're doing sampling and statistical analyses, whereas with machine vision, the promise is to get information from every single part, 100% production.
Could you share a use case for a machine learning application that you've worked on yourself?
Sure, absolutely. So just to get into that, just a quick description of what machine learning does. Again, the big buzzword is deep learning, and a lot of people know what deep learning is. Machine learning is also an algorithm that can learn, and the intent of a machine learning algorithm is to deliver a couple of things that we hear in the world of deep learning, to deliver classification and segmentation without having to explicitly program the analysis in raw code. So we teach a particular algorithm, and there are several that are very important. We don't need to get into all of them, but let's say an algorithm like the support vector machines, I'll just to use a buzzword there. We set up an algorithm with appropriate data, and then that algorithm is capable of either classifying groups of that data or segmenting that to identify a particular object or a particular thing. One of the real interesting uses and this is more of an advanced use, is in classification, and one that I've looked at very recently is in wood classification. The differences between wood have features that are based on color, maybe based on edges, maybe based on time analysis of the features in the wood. And that data then can be fed to a machine learning algorithm. And the machine learning algorithm over time and over enough supervised learning samples can then classify quite reliably those differences without the overhead of a large convolutional neural net model as in deep learning. To be fair, in comparison with deep learning, machine learning requires work on the data in advance. In other words, if we know we're going to, one other one that I've recently looked at is in color segmentation. If we know the colors, we need to provide the data from those colors to the machine learning model as input data, and then the machine learning model learns from that, contrasting that to deep learning, which is designed to just take the image, a labeled area of the image, and use that for the classification. So there's a couple there. Anywhere where we need to do quick segmentation and or quick classification, but have the prerequisite data available in advance, those are good candidates for machine learning. Just one more word on that. A lot of people are familiar with the idea of algorithms that learn and work on data, or at least the idea of learning and working on data outside of machine vision. For example, statistical analyses of data and analysis of production data, for example, in the quality realm. We have reams and reams of production data and maybe want to identify trends or to identify things that are happening within that data to improve processes. Interestingly enough, machine learning is used quite often in those classifications and that segmenting that data, even to the extent where sometimes we think it's deep learning, but it's really in the background machine learning that's used for the data classification.
So for people who are interested, David's session is Tuesday, October 21st, the first day of the show. Hope to see you there.